Welcome back, students. Today we're going to learn something incredibly important to the world of computer science, and that's how to store information within our program. So in order to do that, we got to figure out how variables work, and to use variables we need to know about the basic data types. Today we're going to learn just a couple of them. So what is a variable? Well, just like in math class, a variable is just a name that we assign to something that might change. In the world of computer science, you have different types of variables. For example, you might want to keep track of players' score, or you might have an app where you need to keep track of different users, or in computer science notes there might be different fonts. Well, in order to store the fonts that are used in this, the PowerPoint program is using variables to store that information. You can think of variables as just containers that are meant just to store pieces of information. But with Java, it's a little picky about what type of information you put in the container. You have to tell it, whenever you create a container, what kind of information is going to be stored in it. Otherwise, you could get errors. The best way that you can think about variables is to imagine them as boxes in memory. And each box can contain different information. Now, whenever you create a box, you need to tell it what kind of information is inside of that box. Right now we're going to start off with three basic types: whole numbers, decimal point numbers, and text. Keep in mind also that variables, by definition, can vary. So just because a box currently has the number 37 in it, later on we could change that and have that box have 24 in it instead. Let's look at our data types a little bit closer. First is the int data type. Now, int is short for integer, and in algebra you probably learned what an integer means. Basically, it's a whole number. So here's some examples: 1, 42. You can even have much larger whole numbers. In Java, what can be stored in an int data type is actually fixed. You can't go to numbers greater than about 2 billion. So you can go anywhere from -2 billion up to 2 billion. But if you need to store a larger number than 2 billion, you'd have to use something other than the int data type. That's just because of how much memory it takes up. But for now, 2 billion is a pretty big number, and it can do pretty much anything we want to do in class. Keep in mind, the integer data type means whole number, so you can't have any decimal places. If we want to use a decimal, that's our next data type, the double. Double variables are also known as floating point variables, but they're just numbers that contain a decimal point. So here's some examples: 3.14, and even this one here, 9. We could store 9 in a double. It's just that Java is going to treat that 9 as if it was 9.0. Anything that's a double will always have a decimal point. So if you don't put a decimal point, Java does it for you. Lastly, we need to talk about the string data type. The string data type is how we can store text information. So here's some examples: hello world, someone's name. You can include lots of information, 2 sentences all in one string. Check out this one right here, 1, 2, 3, 4. Now that's not storing the number 1, 2, 3, 4. That's storing the word 1, 2, 3, 4. So Java doesn't actually see that as a number that we could do math with. It sees it just as the characters. So imagine that you had a string that was your address, and you had 234 Mockingbird Lane. The 234, it doesn't see those as numbers. It's just part of the name of that string. Something else worth noting here: whenever you write the word string, that's a keyword in Java that has to be capitalized. The S must be capitalized. And that's because string is actually not a primitive data type. It's actually a class name, and you'll learn more about that later. But for now, just remember that string has to be capitalized. So now that we've talked about different types of variables, how would you actually create them in Java? So here's what code would look like to create those variables. To create a variable in Java, you need to give it 2 pieces of information: what type of data is going to be stored, and what the name of your variable is going to be. Right now we're going to limit ourselves to just using the int, double, or string data types, And then with name, you can pretty much call it whatever you want. And we'll talk about the rules later on for how you can name your variables. So here we have 3 examples. We're declaring a variable called age that can store integers, declaring one called tuna price that stores doubles, and one called name that stores strings. So at this moment, you can imagine that in memory, Java creates 3 boxes. One called age, one called tuna price, one called name, and they're capable of holding this type of information. They don't currently have any information in them, but they're ready to go. Declaring just means that you've created a place in memory to store the data. Now that we've created some variables, we'll actually need to store some information into it. That was the whole reason we created it, right? So here's how you could do that. In our variable that we created called age, I want to put the value of 100 in there. So whatever I put on this side of the equals will get stored into age. The equal sign is called the assignment operator. So it's basically saying 100 is the value assigned to age. 3.99 is the value assigned to tuna price, and Henry is the value assigned to name. Notice that because Henry is a string, we need to put it in double quotes so that it knows where it begins and where it ends. So we talked about how to declare variables, and then we talked about how to put value into them, but you can actually do all that in one line. Here's an example of that. Declaring and initializing variables all in the same line. So we can say int age equals 100. What this means is create an integer variable called age and then put in the value of 100. Whenever you put the value in at the time that you create the variable, it's called initializing because it's the first time that you put a value in there. It's the initial value. Here are the 2 ways we've learned to do this so far. You could declare the variable and then assign it a value, or you could declare and initialize in one step. Both of these do the exact same thing. It's important to note the direction that data flows whenever you're using the assignment operator, or the equal sign. So if I have 2 variables, one called my age and one called Fred's age, let's say that my age is 36 and Fred's age is 42. What happens whenever it sees this line of code is that whatever is in Fred's age, in this case 42, is going to be stored into my age. So my age used to be 36, and now it just got assigned the value of 42 because that's what was in Fred's age. Data flows in this direction on the equal sign. Some people make the mistake and think that because my age is 36, Fred's age will then become 36, and that's data flowing in the wrong direction. That's not the way Java does it. Alright, and on our mission to become super efficient, you can declare multiple variables on one line. So if you needed to have 3 integer variables, one called age, one called num, and another one called x, and you wanted them to have the values of 100, 2, and 50 respectively, you can do all of that on a single line of code. You say int to say, hey, I'm declaring some integer values. And you say the first one's called age, give it a value of 100, and then you use a comma to indicate that I need to declare some additional int variables. So do one called num, give it a value of 2. Let's do another one called x and give it a value of 50, and the semicolon indicates we're at the end of our statement. This only works if all of the variables are of the same data type. So I couldn't declare an int, a double, and a string all in the same line. That wouldn't work. But I could do 3 integers, I could do 3 doubles, I could do 6 strings all in the same line if I wanted to. Here are some key vocabulary words that might show up on future tests. We need to talk about the word variable versus the word literal. So whenever I say variable, we're referring to the actual name that we've given to our storage location. I've declared a spot in memory called Apple that can hold an integer. Apple is my variable. 12 is the literal value that's being stored in Apple. So if I say what's the literal here, it's 12. What's the variable? It's Apple. Here are some common mistakes that people make, and I'll show you why those are wrong. Int apples equals 299. Well, obviously this doesn't work because 299 has a decimal point and it's not an integer. So you're trying to store something that's not an integer into an integer. That'll give an error. This also gives an error. Int burgers equals 12. Well, that's fine, it'll create a place in memory to hold 12, but then you try to create another place in memory, int burgers equals 6. Well, you can't have two variables in memory with the exact same name. So this will give an error. If you wanted to say int burgers equals 12 and then you wanted to change the value of burgers, you don't need to declare it as an integer again. You could just do that and then the value would change. You only have one variable in memory. It was 12 and then it became 6. By saying int, you're asking Java to create a new variable in memory. Alright, some other problems. Double cost equals $15.99. This doesn't work. Double has to be lowercase. Both int and double are primitive data types and therefore lowercase. Why doesn't this one work? String needs to be capitalized. Lowercase string doesn't mean anything to Java. This S needs to be a capital S. String your name equals Bob. Well, this isn't going to work because we didn't put Bob in quotation marks. So Java doesn't know that we're referring to the string Bob. What it does whenever it sees this Bob is it looks into memory to see if there's another variable called Bob. And when there isn't a variable called Bob, it'll give an error. It'll say, I don't understand this identifier. So you would need to put the double quotes on it to indicate that we're not talking about a variable Bob, we're talking about the literal Bob. I alluded to this a second ago. You can reassign values to your variables. Int apples equals 12, so that's declaring and initializing. We created a new variable called apples and put the value of 12 into it. Then later on in our program, we change the value stored inside of apples. So at first it's 12. When this line of code runs, the 12 is removed and a 3 gets stored in there. Eventually, when the program is done running, the value of apples is 50. Now Java doesn't have any memory of any of these other numbers. So at the end of this code, if I ask what is the value of apples, Java will tell me the value is 50. It doesn't know that it once was 7 or that it once was 6. Those values just keep getting overwritten. Here's another example that shows reassigning values, in this case a string, with printing it to the screen. Now remember that a computer runs the program from the top to the bottom, so we can actually look at this one line of code at a time and see what would happen. String s equals hello. Well, we create a new variable called s. It can hold strings. We put hello in there. And then we say, I want you to print the value of s. So it looks in memory to see what the value of s is, and it prints the word hello to the screen. Then we run this line of code, s equals goodbye. So we've just reassigned s. Instead of hello, s now contains goodbye. And when we run this exact same line of code, this print line s, just like we did up here, we get a different result because now s, whenever it looks in memory, it finds goodbye. So it prints goodbye. Now sometimes variables don't vary, right? Those would be constants, and Java allows you to declare constants as well. You just have to use the keyword final. So looking at this, if we look at just this piece of code, double pi equals 3.14159, that's what we've already seen so far. But you know that pi doesn't ever change. Pi is always going to be 3.14159. So we can put this extra keyword of final in front, saying this is the final value of pi, and it'll never change. Don't let my program change the value of pi. If later on you try to do something like this, reassigning pi to a value of anything else is going to throw an error because it was declared as final. You're not allowed to change it. It's also worth noting that constants should be in all caps, so that's why I capitalized the P and the I. We'll talk more about that in a second. These special assignment operators will be pretty crucial to the lab that you're about to do. We talked about just the equal sign. Just the equal sign lets you put data into a variable, but these let you change the data in a variable in a special way. The plus equal sign means that I want to take the current value of that variable and add to it some number. For example, num plus equals 3 means that whatever value is currently in the variable num, I want to add 3 to it. So if num is 27, then this line of code runs and num is now 30. Similarly, we can subtract a number from our variable. Or we can multiply our variable. So imagine that num is 10. Well, times equals 3, so we take the value 10, multiply it by 3, and that's 30. Put that back into num, so num is now 30. It's now 3 times larger than it was originally. We can also divide, and modulus is another operator that we're going to learn in the next lesson. You don't need to know what that means now, but whenever you do learn modulus in the next lesson, I want you to know that you can also use the special assignment operator with it. So we have learned now how to declare our own variables, which gives us a tremendous amount of power, and with great power comes great responsibility. So we need to make sure that whenever we are naming our variables, that we're doing a good job of it, because Java won't let us do just whatever name we want. We need to know what the rules are. So anytime I say variable name, here's a key vocabulary word for that: identifiers. Identifier and variable name are synonymous. Basically, an identifier is like, how can you identify what space in memory we're talking about? How do we identify what variable we're talking about? Well, we look at its name. So whenever we're creating a new variable, apples, tuna price, we need to know what are we allowed to call our variables. So here's the rules for legal identifiers. Whenever you create a variable name, you have to start with a letter. You can't use any spaces. And you're allowed in subsequent characters to use a combination of letters, numbers, and even a couple special characters, but most aren't allowed. Here are some examples. These are legal. These are okay. Java likes these. Number, 3 dogs, Frank, D2 plus 3, these all follow the rules. They all start with a letter, and then they have letters and numbers to follow. These are illegal. If you try to name a variable using these names, you're going to get an error. A special character, you can't call a variable just the pound sign. You can't start with a number. You can't put a space in your variable name. You can't put a special character in your variable name. These are legal, and these are illegal. But that's not good enough. Just because Java allows you to name variables using this, programmers have all kind of come together and decided that there needs to be more convention in place for understanding what different types of identifiers mean. The reason for this is that you're going to name lots of things in your code eventually. Right now you're just naming variables, but later on you have to write your own names for classes, write your own names for variables, write your own names for methods, write your own names for constants. And it would be nice if there were different sets of rules for each one of these that would help us to easily identify what we're talking about. You know how string was a capital S but int is lowercase? Well, that's actually a clue to us about what's going on there because of our naming conventions. Let's talk about camelCase. CamelCase refers to capitalizing the first letter of every subsequent word in a variable's name, such as voting age, we capitalize the A. Player name, we capitalize this N. Total order cost, we capitalize the O and the C. Because these are variables, we always start with a lowercase letter. But then every time we encounter a new word in our description, we put a capital letter, and that's called camelCase because it's got these humps in them. So if you look here, the variable name area of concentric circle is much easier to read than this area of concentric circle. Those capital letters help to offset, and your eyes can easily see where the words break up. So whenever you're naming variables, you should always start off with a lowercase letter and then use camelCase. You also want to make sure that your variable names are descriptive, so that whenever you see that variable name, you kind of know what it represents. So length, volume of circle, num, Big Macs, those are all good examples of variable names because you kind of know what would be stored there. This would be like how many Big Macs you ate. Here are bad examples of variable names. Length, it starts with a capital letter, so that's breaking the rule of a good variable name. When it starts with a capital letter, that sends a message to other programmers that this is a class name, but no, it's actually a variable name, so you should have used a lowercase. Volume of circle, no capital letters, so it's a little bit harder to read. NBM, while this variable works, no one has any idea what NBM stands for. So that's why it's not a good name. Later on, you're going to be writing your own classes, and you'll see that classes follow those same set of rules about camelCase and being descriptive, but they all start with a capital letter. That's actually why string starts with a capital letter, because it's its own class. You'll learn more about that later. Previously, we talked about constants. Those are variables that are described as final and can't change, so that we can remember as we're coding which ones are finals and which ones are just regular variables that can change. We use this naming convention. With constants, we always capitalize everything. And then we offset words by using an underscore. So pi, gravity on Mars, distance Dallas to New York City. These are all good constant names. Anytime I see this in someone's code, I'm immediately going to know. Anytime I see this in someone's code, I'm going to know those variables are final and can't be reassigned. Also, later on, you're going to learn how to name your own methods. Right now, all we're doing is the main method, and you're not changing the name on anything, but eventually you will. And so I want you to know that this is here. You can refer back to this slide later on in the class to find out how you should be naming your methods. All right, that should be enough to get you started on your labs. Good luck. Enjoying my class? Smash that like button. Don't forget to subscribe and follow me on TwitFace. But hey, that's just a tutorial. A computer science tutorial. Thanks for watching.